The Iron Phoenix. How steam, coal, and tenacity forged the train. A world before speed. Imagine a world where the fastest journey was limited by the endurance of a horse. A world where shipping goods from one city to another took weeks, and crossing a continent was the stuff of a lifetime. This was the world of the early 18th century. Distance was a tyrant. But deep underground, in the dark, damp coal mines of Britain, the heart of a revolution was beginning to beat. It was a heart powered by steam. The power of steam. The story of the train doesn't begin on rails, but with water. Mines were constantly flooding. To pump the water out, inventors like Thomas Newcomen and later James Watt perfected the steam engine. These were gigantic, stationary beasts. They could lift water, power looms, but they could not move. The idea of making a steam engine propel itself was radical. One of the first to try was Nicolas Joseph Cugnot of France in 1769. His steam dray was a three-wheeled monster designed to haul artillery. It was slow, monstrously heavy, and barely steerable. During one test, it crashed into a wall, marking perhaps the world's first automobile accident. The experiment was a failure. The problem was clear. Watt's engines ran on low-pressure steam. They were far too large and inefficient for a self-propelled vehicle. Richard Trevithick, the devil on wheels. The solution came from a brilliant but volatile Cornish engineer named Richard Trevithick. He believed in the power of high-pressure steam. It was dangerous, boilers could explode, but it was the only way to make engines small, light, and powerful. In 1801, he built the Puffing Devil, a road locomotive that carried his friends around town. It worked, but the roads were abysmal. Trevithick realized the engine didn't need a road. It needed a smooth, predictable path. It needed rails. At the time, mines already used wooden and later cast-iron tramways for horses to pull carts of coal. In 1804, a Welsh ironmaster named Samuel Homfray made a 500 guinea bet with a rival that Trevithick's steam locomotive could haul 10 tons of iron along his tramway at Penydarren. This was the first recorded test of a steam locomotive. On February 21, 1804, Trevithick's unnamed engine, which we now call the Penydarren locomotive, set off. It successfully pulled 10 tons of iron, 5 wagons, and 70 men over a distance of nearly 10 miles. It moved at a blazing speed of about 5 miles per hour. But here, the first great difficulty emerged. The locomotive won the bet, but it lost the war. The engine weighed 7 tons. The brittle cast-iron rails designed for light, horse-drawn carts simply shattered under its weight. After just a few journeys, the experiment was abandoned. The engine was put back to work as a stationary machine. Trevithick was a genius, but he was too early. He died in poverty, never knowing he had planted the seed of a revolution. The great adhesion problem. The idea didn't die, but it faced a new, almost philosophical problem, the problem of adhesion. Engineers at the time were convinced that a smooth metal wheel would simply spin on a smooth metal rail. They believed it couldn't possibly grip enough to pull a heavy load or climb even a slight gradient. This led to bizarre and cumbersome solutions. In 1812, John Blenkinsop built the first commercially successful locomotive for the Middleton Railway. His solution to the adhesion problem? He ignored it. His locomotive, the Salamanca, had a large toothed cogwheel on its side, which engaged with a rack rail laid next to the running rails. It worked, but it was slow, expensive, and terribly noisy. Others tried engines with mechanical legs that literally pushed the locomotive along, mimicking a horse. These were evolutionary dead ends. The solution came in 1813. William Hedley, a colliery manager at Wylam, was skeptical of these complex contraptions. He conducted a simple but brilliant experiment. He built a man-powered carriage, loaded it with different weights, and had his workers crank it along the rails to see how much it could pull before the wheels began to slip. He discovered what seems obvious today. The simple friction and weight of the engine itself were more than enough to provide the necessary grip, or adhesion. The myth was busted. Hedley soon built his locomotive, Puffing Billy, the first successful engine to run on adhesion alone. It was slow, clumsy, and loud, but it proved it could be done. George Stephenson, the man who put it all together. Now, the man often mistakenly called the inventor of the train enters the scene. George Stephenson did not invent the locomotive, but he was the man who turned it from a mining curiosity into a world-changing force. Stephenson was a self-taught engineer from Killingworth. He was not a theorist, he was a practical. He had seen the engines of Trevithick, Blenkinsop, and Headley. He saw their flaws, and he understood that the problem wasn't just the engine, but the entire system. The rails, the gradients, the wheels. In 1814, he built his first locomotive, Blucher. It was more reliable than Puffing Billy, but it was still just an improvement. Stephenson's true breakthrough was one of integration. In 1825, the Stockton and Darlington Railway opened. It was the world's first public railway to use steam locomotives. Stephenson was its chief engineer. His engine, Locomotion Number 1, pulled the first train. The difficulties were immense. The rails were still fragile. The engines were unreliable and broke down. In fact, much of the traffic on that line was still handled by horses. Steam was, in part, a publicity stunt, but it was a vital step. The rocket and the Battle of Titans, the Rainhill trials. The tipping point came in 1829. The ambitious Liverpool and Manchester Railway was being built, the world's first intercity line, designed entirely for steam. But the directors were still nervous. Were locomotives reliable enough? Or would it be better to use stationary steam engines to pull the carriages with cables? They decided to hold a competition, a contest, the Rainhill Trials. A prize of £500 would go to the locomotive that could prove its speed, reliability, and power. 5 engines entered. 3 were the center of attention. The Novelty, the Sans-Pareil, and the Rocket, built by George and his son, Robert Stephenson. The Novelty was light and fast, but its complex boiler sprung a leak. The Sans-Pareil was powerful but too heavy and cracked a rail. And then there was the Rocket. It looked different. It wasn't just an assembly of parts, it was designed. It had 2 key innovations that solved the steam engine's greatest problem: inefficiency. First was the multi-tubular boiler. Instead of one large flue passing through the boiler, the Rocket had 25 copper tubes. This dramatically increased the heating surface area, making steam far more quickly and efficiently. Second was the blast pipe. Exhaust steam from the cylinders was directed up the chimney, creating a powerful draft. This in turn pulled air through the firebox, making the fire burn hotter. The faster the engine worked, the stronger the blast, the hotter the fire, the more steam it produced. It was a brilliant self-regulating feedback loop. The Rocket annihilated the competition. It completed all the trials, pulled loads, and, most astonishingly, hit a top speed of nearly 30 miles per hour, 48 kilometers per hour, on one run. This was faster than the fastest racehorse. The public was stunned. The Rocket was the template for almost every steam locomotive built for the next 150 years. A world bound by rail. The Rainhill Trials were not just a victory for the quote-unquote Rocket. They were a victory for the locomotive itself. The Liverpool and Manchester Railway opened in 1830 to overwhelming success. Railway mania began. The difficulties had been overcome, not by one single genius, but by a chain of problem solvers. Trevithick proved it was possible. Headley solved the problem of adhesion, and the Stephensons made it efficient and reliable. They had taken the raw power of steam, bound it in iron, and set it upon rails, forever changing our concept of distance, time, and the world itself. The tyranny of distance had been overthrown.